I went ahead off screen and I just applied some more solder to some of those connections. I'm quite happy with that. They're connected down quite well, and the next thing we need to do is add some other connections for our ancillaries. So I've just got some red and black wire here. I think it's probably 20 gauge, and we'll add these in now because if you forget to do it, it'll be such a pain to try to pull everything apart later on to be able to get these wires connected up. So I'm going to have to add a bit of heat here. So I'll add in the black wire here. I need to try to get some heat into. So I was struggling to get the heat with that smaller iron, so I've just swapped over to the bigger iron. There we go, got a much better bead already. Alright, so now we've got some black and red wire connections for ancillary systems. For a little bit of added extra measure, what I think I'll do is I've got this stuff called liquid electrical tape, so I'll add some of that into the contacts, and that should hopefully protect some of the connections as well. It's a matter of just spreading it on. It's pretty runny, so a bit more of a bird's eye on it. Okay, second leg are lined up. It's a bit fiddly. Okay, so third leg. So up to 3, just get the fourth leg running. It's worked out a little procedure. It's because I threaded those black standoffs, I need to put them in first. If I hold them, it makes it easier to do the screws up. It's a bit tight. There we go. done. Now it's just a matter of sliding these up. Ah, that's tight. There we go. Right. One's in. Let's see if I can pick up the hole. There we go. There's the hole. It's better. Kicked itself over a bit. Perfect. Screw it all up tight. And it's a matter of adding some of the nuts. And what did I do with okay. But otherwise, fundamentally, we're getting there. So while I'm waiting for the iron to heat up again, because I'm going to put 3mm bullet connectors on the ends of the ESCs, decided I'll go and add in the vibration dampening. The holes are of course made to sit inside the gullet. So you've got to really jam everything in to get it through the hole in the G10 here. So slowly, just push it all through. And there we go, quick twist, just got them on. So there's our vibration dampening between the clean and dirty sections. 3mm bullet connectors are now connected all up. I'll go through and add some heat shrink over the top of that so we don't get any issues with shorting. The thing to consider here is when you connect up your motors, in the Naze world the motor layout is 1, 2, 3 and 4. 1 and 4 have to spin in the same direction, whereas 2 and 3 also need to spin in the same direction. And there's a quick visual of that. So motor 1, motor 2, motor 3, motor 4. You can see the direction of spin between 1 and 4 is the same, and 2 and 3 is the same. What does that actually mean? For the quad, it really means that because these are 3-phase motors from an output perspective and an input from the motor's perspective, we actually need to change the polarity of 2 of the wires to get the motor to spin in the opposite direction. So motors 1 and 4 are the ones that will need to go and change the polarity. So in this case I think what we'll do is we'll just pick the red and the blue, and we'll just connect blue to the red and red to the blue wire. Whereas on this motor here everything will be a straight colour connection. So black will go to black, blue goes to blue, and red to red. Simple as that. And that sets us up so that we have the props running in the right direction. In case we make something or make a mistake at any point in time, it's easily fixed. All you have to do is just change the polarity of change 2 of the wires over, and the motor will spin in the opposite direction. It's as simple as that. One thing I could recommend that everybody should do is go ahead and label your ESC leads, because it's going to be a bugger to try to find out what it is. So I've gone ahead 1, 2, 3 and 4 for my ESC leads, so when I pull them up I know where they need to go in to the Naze board. The other thing that I've done, I just quickly put an F and a B on here as well, just to understand the orientation. So when I'm looking at my motors, I know which ones I need to have reversed and which ones I need to have straight. Sorry, in this case it's reversed on these two and straight on the wiring through these two. I'll show you what I do, but I mean it's absolutely simple as can be. So 2 and 3 motors are straight through, so black goes to black, red goes to red, blue goes to blue. I changed it up this time, from what I said before. I'll cop the blues together, but I'm going to have red and black are swapped, and yeah, the red and black there. So what I'll do is I'll tuck all these in, we'll get some cable ties, and just do some cable tying, so that's all nice and neat. So I want it this way. Always get it the wrong way. There we go. Try to be consistent based on what I'm doing. And the other thing I did was run a cable tie through them all. Try to keep them all locked together. Don't overly do up the cable ties. Should be snug, but not fiercely, locked in. It's reasonably neat. I would have liked to have somehow incorporated it further inside, but just the way I've gone ahead and run my wires, it's just not conducive to it. So, overall, however, it's looking like a quad. It should virtually fly the way it is, but of course we need to start putting the top deck and all the other ancillary bits and pieces. So I'll go ahead, I'll fit the top deck on and start working out my layout for my Naze board, and making some standoffs and adding the standoffs that we machine, those 1.5 inch ones, to the bottom plate of the top deck, so that it's got something to connect to, because you can't do it later. Quick amount of work, and I've been able to get the top plate to seat itself through the rubber grommets, and all I did was I quickly added a screw with a nut on the bottom, and purely just to hold it into place, because I was a little bit worried that it might pop off. I need to machine 2 more standoffs to go on the front here. No big deal, it won't take me long to do that, but all the rest are in place, ready to have the top attached. There's a camera plate that goes off the top here as well, so I'll attach that as all one piece when I get the chance to. The Naze will have to go into here, so I'll have to make some standoffs for that as well. So there's some small ones here that I've got. I think I might look at using something around this size. It seems to be a good height, so yeah, we'll see how it goes, and we'll attach that. The Naze board's a really awesome unit. It's small and just really locks the quad in. I've tried many other boards, but this is my preference at the moment. So we're going to install the Naze32 board from a Buse mark into the quad. I created some standoffs already, which I mentioned before. I'll just show you a bit more of a close-up on that. So we've got 4 little standoffs ready to accept the Naze board. Let's screw it on. The other thing I want to quickly mention is that there's an arrow located right here on the Naze board. That gives you the direction of travel. We'll be placing it at a 90-degree offset, so within the software itself we'll have to tell the Naze board that it's orientated at 90 degrees. And the reason I'm doing that is purely for accessibility to the USB. If I was to have it accessible through the back here, it's a bit of a pain because we're going to have those standoffs. So if we have it at 90 degrees, then I can come in on the side with a USB and connect in, configure the unit at any point in time. Just means we've got some header pins which hang out the side here. These are for the motor, and we've got some other header pins here which are for the receiver itself, which isn't a big problem because I'm going to use PPM, so it's just 3 connections. It's the 2 power plus 1 signal, and these other header pins over here are for battery voltage monitoring and all that sort of stuff, and I tend not to use these. So let's install the Naze. I'm using some 3mm plastic washers, 3mm plastic screws, just purely because I didn't want to use metal ones on a electronics board. And we'll just go ahead and screw that in. Give it a bit of a tighten, too much. Nice and secure. This is going to really save us a lot of grief. It's telling us the motor positions already without having to retrace it. The way that the pinout works on the Naze board is, this is motor 1, 2, 3, 4, 5 and 6. And on the outside here, the outermost, or the pin that's within the center of the board, are the signal pin. So in other words, it's for these ECs, it's the white cable. So we just need to make sure when we put it in that the white cable is on the top. So I'll go ahead and do all the connections. That's number 1. I'll do number 2. I think it'll be easier to put the actual cable in. 2. This is 3. It's a little bit tight. So that's this motor right in the back here. 3's all the way home, and there's number 4. Make sure I get it the right way around too. Excellent. Okay, there's number 4. Just do it like that so we don't have too much trouble. And I think I'll just put a little cable tie around that just to secure it all, if I can find it. Here we go. Once again, not too tight, just purely to hold the cables in place. So that's how simple it is to install the Naze board. And I'll find a cable for the PPM lead, and we might as well install that at the same time. So I've just got an extension cable here, and the yellow in this case is the signal wire, so we'll put the signal wire on pin number 2 because it actually goes, pin number 1, because it goes sort of like plus, minus, and then the signal. So we'll connect that in. There we go. All our connections are now made to the Naze board that we need. If you're wondering what these toroidal magnets are doing, they come standard with the ESCs that I buy, and they're purely there from a noise perspective. So what they'll do is, it's otherwise known as a choke. So any noise that's induced from the ESC itself, or the switching circuit, is suppressed at this point. It basically blocks the ability of any noise that's coming through to be passed through to the board, which is really cool. But you know what, they're a real pain in the ass because they're such a big magnet, and you know, they just get in the way of everything. But that's what these magnets are for. They're basically to suppress superfluous noise. The camera mounting plate's quite simple. So the connector on this side is used to provide the output. So what we'll do is, with the notches on either side, been up and down on the top and bottom, we'll push the plate through, and we've got these spaces that have been made up to give us a bit of space in between the camera plate and the front body. It's just a matter of then jigging it up. This one doesn't want to go through, so I might just put all of them through. First, and get rid of the flies. Okay. There we go. So as I said, we need that to be on the right hand side, which it is, and now it's a matter of, what I need to also mention is that I actually went through previously and I drilled and tapped these. Well, I actually only just needed to tap these to 3mm, so, or 2.5 actually. I've got some 2.5 long screws, so I just ran a tap through that. Now it's just a matter of doing it all up. Let's note which corners. Just push it all down, make sure I've got clearance, it's going to sit beautiful. So just all up. The opposite corners. Fantastic. Just give it a little tweak. So it doesn't come loose, and we're done. So they just protrude through. So they protrude through a little bit, but that's okay. So we've got the plate with the camera all inserted. Clever idea from Johnny. Installation of the camera's simple as well. So once again, the connector on the right, I like putting it on this side, and we'll just locate it into one of the holes. Tight fit, but better to be snug. There we go, and that should pull up when we put the top plate on, and the screws for it as well. So, camera plate now fitted. The other thing I've just gone ahead and done is I've just added the adapter which will hold the receiver, and just the 2 offsets which are basically the battery holders. So in other words, it won't let the battery go any further forward than that position. I had 2 in just in case in a crash the battery moves forward, it'll pull out the first one and hopefully not the second one and then crash into the nose board. I've had that done before where it's actually pulled one out and the second one's saved the battery going through the nose board.